Okay, so now we're going to start with question number 21. We looks like we have to do the best fit, best which equation best models the data. So let's bring up the calculator. Okay, so when we use our calculator and we're doing best fit, we're going to go to Stat, Edit, and we're going to put in the values 1, 2, 3, 4, 5, 6. Okay, and then 93, 149, 174. Hear my dog bark in the background. 161, 27. Okay, so we got, let's see, 120. Uh-oh. How come I have, oh, I didn't have a 6. What the heck? I don't know where that 6 came from. Anyway, I've got 1, 2, 3, 5, 93, 149, 174, 168, 127. Alright, and I'm looking at, looks like I've got a quadratic, I've got a linear, I've got a quadratic, and I've got a linear. So, I gotta decide which one's, this is the best one. So, let's see. I'm going to hit Stat, Calc. I'm going to do, let's do a line of best fit first. Okay, it looks like 8.7 and 1.16. Looks like this one right here. Let me turn my diagnostics on just to see where it's, what kind of, let's see, gotta go down to D. And your calculator's diagnostics, I'm sure, won't be on because when we reset the calculators, they defaults by turning them off. Alright, so let's see what we got. Do this a couple of times. Okay, this is not a very good line of best fit, so hopefully you don't pick that one right away. So let's try and look, see right here where the R is, you want to make this thing as close to 1 as you can, and 0.4159, that's not really great. That means it's like 40% accurate. So this one right here, you're definitely not going to want to pick that one. So that's kind of tricky. That's not very nice. Alright, so what we're going to do is we're going to go hit Stat. We're going to look at the quadratic and see if that's better. So I'll pick number 5, hit Enter, and that one matches this guy right here. And if you look at it, I don't know what happened to my calculator. If you look at it, 0.9995, that's about as close to 1 as you're going to get. So that is telling you that the accuracy is really good. So that's what you want to go with. So 0.9995 is good, so I would pick C. Okay, next one. Problem number 22. We're looking at a log. We want to know, now this part's important. This means that C is supposed to be a negative. Okay, so we want C to be negative, which means when this is negative here, that means my whole graph scoots down. Well, it's important for you to know where the parent graph is, so if you put this part in the calculator, you can kind of see. I wonder if my calculator is still working. Nope, it's dead. I'll have to restart it again. But anyway, the log function, the parent log function, they all look like this. I mean, but it should be basically, let me just color it out. If you take this is a horizontal, vertical asymptote, and then here's the 1, and basically the graph kind of goes like this. Okay, and then this gets really, really, really close to 0, but doesn't make it. And so basically, we want to know, they basically want to know is which graph would show the function moving downward. So D is the only one that moves down. This one moves to the right. This one moves to the left, and this one moves up. Okay, so, and again, if you get stuck, put this guy in the calculator. That's your parent graph. put that in, look at it, and then look at the other graphs. And basically it's asking you in a weird way what happens when I shift the calculator in the and then when C becomes negative, which means you're moving it down. Okay, find the inverse. Now the way I do this, and I've taught my kids this, is basically you start with x. You just tell me what you've done to x first time around. So I'm cubing it, and then I am subtracting 8, and that gives me to the y value. Okay, then I change y to x, and I'm down here writing the instructions on how to do the inverse. I add 8. Instead of cubing it, I'll be taking the cube root, whatever I got, and that should give me my new inverse. That's supposed to be -1. I don't know what happened there. So this bottom line tells you exactly what to do. So you take x, add 8 to it, take the cube root, and look how fast you can get that done. And that's C. Okay, pretty quick. So again, the top line is what you would do forwards. In other words, if I gave you the number in 4x, what would you do with it? You would cube it first, then you would subtract 8. So that's how you write the instructions. And then you write the instructions underneath it of undoing all those instructions, but you're going in this direction. So ultimately what you're doing is you're doing the opposite operation, which is called an inverse operation. You're doing the opposite operation in the opposite order, and that's how you get the inverse. Alright, so the heights of 200 kindergarten students are normally distributed with a mean of 40 inches and a standard deviation of 1.8. Approximately how many students, how many, it's very important, have a height between 37.3 and 44.5. Alright, so I'm going to make myself my little, wow, let's try that again. Can I undo that? Probably not. Let's see. Yes, I can. Okay, here's my mean. My mean is 40, and I'm going standard deviations. This is 1.8, so this would be 41.8. This would be 43.6. Okay, and then the next one over that is 40. 45 point. Let's see, 4. Okay, and then I'm going the other direction. I'm going to go 1.8, which is 38.2. Alright, yeah. And then one more standard deviation, which is 36.4. Alright, but what are you interested in? You're actually interested in the area between 37, which is somewhere in here, and all the way to 44, which is all the way in here. So you're interested in all of this. Okay, so what is important for you to know is what you don't want. So basically, I don't want any of this, and I don't want any of this over here. Alright, so what am I going to do? Well, I'm going to figure out a couple z-scores. What I'm trying to do, if I could make that a much better looking shade, because that's really kind of ugly, is, let me see if I can kind of give you kind of a better look at that. Basically, you're looking at two pieces, one here, and you're trying to figure out all of this area in here. Okay? And I could sit there and color all day, but the idea is that you're looking for this area in here. So what I'm going to do is I'm going to find the z-score at 44.5, and I'm going to take away from it the z-score of 37.3. Okay, when I'm not z-scores of, but when I finding z-scores using these numbers. Alright, so 37.3, that's really ugly, but that's what I'm, let's see if I can make that a little prettier. Okay, 37.3. Alright, so I'm looking at 37.3 and 40. And the reason being is, remember your z-tables. Let me bring that up in a second. Let's see, z-tables. Okay, if you look at your z-tables, let me bring this in play. Let's see, will it move it for me? There we go. Okay, here's my z-tables. If you notice that the z-tables have the shaded part is always to the left. You can look at this side of the paper, which is before you get to the mean, and then the other side of the paper, which goes after the mean. The highest point is the mean. No matter what, it's always registering to the left. So all your calculations that you're doing are all from the left. So when I do this, I want all of this all the way, so 44 point, what is that, 44 point, the heck is that, 44.5. I'm going to take all of that. That'll give me all of this, and then I'm going to turn around and take out a little piece of it. So I'm going to turn around and take out the 37.3 because I want in between. So it's kind of like you're doing your, if I could draw on this, it would look something like, ooh, it didn't let me draw on it, I guess. Let's see if I bring that back up again. Okay, no, it's not going to let me. So that's what we're going to do. So let's figure that out. We'll bring this back over in a second. Let's figure out those two. So what we're going to do is you follow your formula, and let me grab your formula sheet. I got that too in my handy dandy computer here. Alright, here's my formula sheet. I'm going to look, there's all my z-score stuff right here. Okay, and in fact, if you don't even know what everything stands for, it says up here, X represents the data set that we're working with, which is each one of these numbers. The mu stands for the mean, and the little, this is a lowercase sigma. This stands for the standard deviation. So we're going to do that. Alright, so we're going to take 30, first thing we're going to do is we're going to do 45.5, and we're going to take away from it the mean. Okay, then we're going to divide it by the standard deviation, which is 1.8. And since my calculator doesn't come out that easily, I'm going to just use one of these cheapy-cheesy things. Okay. Alright, so I'm going to take 44.5, take away from it 40. I could have done that one in my head. And then divided it by 1.8. Okay, 2.5. 2.5. Now, if that kind of sort of makes sense. If you look, here's one standard deviation, here's two standard deviations, and the next thing I want is kind of somewhere in here. Okay, so that's where I'm kind of looking at, somewhere in between. So, like, here's my third standard deviation right there. Anyway, I got 2.5. And next thing I'm going to do is I'm going to do the same thing. I'm going to do 37.3 minus 40. Why I can't get this thing to not get so ugly, I'm not quite sure. Okay, so that's supposed to be 37.3. This is going to be negative 2.7 divided by 1.8. And let's grab the calculator. Let's see, clear 2.7. I don't know how to do negatives on this thing. Oh, it doesn't matter. Divided by 1.8. I just have to remember I have a negative. 1.5. 1.5 negative. So I've got to go look up those two. These are z-scores. So I'm going to go look up that one. I'm going to go look up that one. So I'm going to grab my z-scores. And I'm looking up 2.5. So 2.5. Now, since I don't have a hundredths place, 2.50 is right here. So you do 0.9938, which is what that was on there. And this is just not being cooperative, trying to put all these things in at once. Okay, and then where did my, okay, so again I got that from 2.5s right here, 99.9938, and now I'm going to look up the negatives, and the negatives on the flip side of the paper, which is I'm going to negative 1.5, which is right there, 0.0668, 0.0668. Now I'm going to subtract those two because I'm interested in the probability of it occurring between those 2 points. So I'm going to subtract 0.9938 minus 0.0668. That gives me 0.927. Now, if the direction said, what is the probability, then I would be done. But I have to take the 0.927 and multiply it by the number of kindergartners I have. okay, to get my final answer, because it says how many students. So let me grab my calculator again, since I already have it here. Cool. I want to hit times 200. And your answer is 185. Now they'll probably take 185 or 186 because it's a student, so you have to approximate. So 185 is what I would guess. That's it. Okay, on to question number 25. Alright, question number 25 says, what is g of h of 12? Now, my class played the game, the passing the card game, where it was a kind of a race, and I gave them a card and I passed it on. So we did like 4 of these in a row. But the rule is whatever letter is closest, function is closest to the number they give you is the one you start out with. So you're going to take this 12 and you're going to plug it in for x. So you do 12 divided by 3 minus 7. Wow, 12 divided by 3 is 4. 4 minus... What is going on with my... negative 3. 4 minus 7 is equal to negative 3. And then you're going to take this, and then this number gets put in right there. So 2 times negative 3 squared minus 5. So that's 18. You can put this all on your home screen if you wanted to. So your answer is 13. So that's what you would put here, 13. Most likely the stuff you have to put in the blanks are going to be fairly easy to type in, so they're not going to give you something super complex. Alright, it says here graph the solutions to. Alright, so this is a absolute value equation. So this is not that easy. So we're gonna try to see if we can do this, and then we're gonna go look at the picture and see if we got it. First of all, with an equation, you have 2 dots. You're gonna get one answer that's to the left and one answer to the right. So you're gonna have 2 answers on here. You're not gonna have any shading or any of that because it's not an inequality, it's an equation. So what you're gonna do first is you're gonna solve this equation. Hopefully my tablet will behave. You're going to solve that one, and then you're going to solve this one. See, it's already misbehaving. I don't know what's going on with it. I need a driver or something. I don't even know. Part of it is I have a lot of things running behind the scenes. It gets kind of quirky. Alright, so I got to solve this, and then I got to solve that. Now, solving this is not that easy, but you can multiply everything by the common denominator, which is 8. So that changes this to x minus 4 into 8 is 2 times 1 is 2, and then half of 8 is 4. So the answer to that one is x is 6. Okay, so the dot goes there. And then I got to do the same thing here. I could pretty much just copy what I got here, x minus 2, except the only difference is this is negative 4. And add 2 to this. Why did they ask this question? That is a good question. I don't know why I'm having problems with the negatives, but here they are. And there's my other one. I don't know what's going on, but the idea behind this is that they're trying to test how well you do with your rational expressions like this, and also absolute values. So they're kind of doing a dual problem. Remember, they only have 50 problems that count, so they're going to try to do as many kind of math questions as they can. Anyway, you can figure this out. I can also put it in the calculator and kind of get an idea of what it looks like. But it's easier, and I can go look up the answers if I wanted to. For instance, I could, let me put the calculator up here for you. Let me start this up. But what you would do on this is you put it in the calculator. Let me bring this up for a second. Let's see, where are you? Are you starting yet? Okay, how do you do this on the calculator? Because a lot of you guys I know are probably wondering, how the heck do you do this on the calculator? Alright, so you're going to put this in the y equals. You're going to go in and type in exactly what you see. That's, whoops, I need absolute value though. Second catalog, first thing. And I'm going to put in, again, anytime you have a fraction, put in parentheses so the calculator knows what it's looking at. Minus 1 divided by 4. I get that right? Okay, and then close that. Alright, so I'm looking to see when it's a half. So I'm going to go to my table, and I'm going to try to find a half anywhere on this, and there's the 6. See, 6 is 1/2, so that gave me an answer. And there's -2. That also gave me a half. So I just confirmed that both my answers were right. But you could do that if you wanted to. You could try that out as your first resort instead of having to do all of this. Type this in and try to look for this in the y equals column. So when you have the graphing calculator up here, you're looking for a 1/2, and there's one right there as a decimal. And then if you go further down, there's another one somewhere down here. Remember, there's always two. There's always two answers unless this is 0. Other than that, you're always going to have two answers. One going off to the left of the number line and one's going on the right on the number line. Alright, so what are we doing with this one? The zeros of the cubic. Oh, this is going to be an easy question for my group. Alright, so you're going to put in an f of x. Okay, if these are the zeros, then we write the factors. So x plus 1 for that one. And then this one is going to be, now remember what we do here, we put x plus 2/3, and I'll fix that in a second, and then you're going to put x minus 5. Now this 3 belongs up front. Alright, so we have to circle our answers, so that's an answer, that's an answer, and that's an answer. So make sure you click all 3. If you miss one of them, the answer is wrong. Alright, 28. The volume of a container varies jointly with the square of its radius. The container, blah, 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 blah. Alright, so there's usually 3 steps to these types of problems. The first question, or the first sentence, always gives you help you write the formula. So I'm going to do that. So if it says the volume of the container varies jointly. Okay, jointly is like doing directly but twice or 3 times. So V, as soon as you see varies, okay, you should automatically have equals K, no matter what you do. Jointly with the square of the radius and the height. So since they're jointly, they're doing the exact same thing. So there's your formula. Alright, so that's the formula you're going to use. And then what they want you to do is they'll give you enough information on the next sentence, so sentence number 2, will tell you how to get to K. So we're going to fill this stuff in. So the height is 10. Okay, the radius is 6. And the volume is 377. So 377 equals, and I don't have K, equals 60K. Divide by 60. Okay, alright, I gotta do this on my handy dandy cheapy cheesy calculator because it's faster. Alright, we're gonna do 377 divided by 60. Ooh, 6.28. Alright, so I'm just gonna put 6.3 just to. Alright, 6.3. So now it says, what is the volume? So I don't have that. I do have the 6.3 part. That's your K. Of a radius of 4 and a height of 4. So all I have to do is 6.3 times 4 times 4, and I'm done. So let me grab my handy dandy calculator. Okay, actually I'm going to leave this because that'll make the K even more accurate than what I have written. Times 4 times 4 equals 100 point, I think that was said 100.5, is that what that said? Yeah, 100.5, and you would just put that in here. So there's kind of a step process. The first one's always giving you the formula. The second one will give you enough numbers to find K, and then the third one uses K and gives you 2 out of 3 of the numbers, or always leaves you 1. You can tell, you know, in the question which one they're not going to give you. In this case, they didn't give you V. Alright, I'm going to stop at 30 and stop this video because we are up to 24 minutes, so I'm going to break and because this is pretty easy. Alright, it says place points on the x-intercepts of this graph. Now I believe with this you're going to use your pointer tool, which is this guy. Let's see, this is my dot tool, I believe. So your pointer tool, I think, is your I think it's the pencil, honestly. I'm not entirely sure, but I think that's what it. But I think there's some pointer tool or whatever. It'll allow you to put points on there. Actually, no, it says place points, so it's probably points tool. I don't know. One of the two is going to let you to do that. So it's either the pointer tool or the dot tool. Either one of those. Place on the x-intercepts. This is probably the easiest question you'll ever get. Okay, there's one. There's another, and there's another. That's a gimme. That is, if you don't get that one right, then you need to give it all up, because that's probably the easiest question you'll ever get. Alright, so I'm going to stop here, and then I'm going to do the last 7, right? Yeah, do the last 7.